Hello children. Let us continue with chapter 2, Polynomials of Standard 9. Earlier, we have studied about remainder theorem and factor theorem. And we know the difference between those two also. Now, in this exercise, we are going to use both the theorems. So, let's begin. Question number 1. Determine which of the following polynomials has x plus 1 a factor. Now, 4 sub-questions are given. We will go on solving each, most of them. Here we are going to find out whether this x plus 1 is the factor of it. So, the very first sub-question. P of x, it is given to be x cube plus x square plus x plus 1. And our g of x is x plus 1. Now children, we are going to equate this g of x, that is x plus 1, to 0, and this is how we get the 0 of this polynomial. And in this case, it is equal to minus 1, that is x is equal to minus 1. And now, as we have already done, we are going to use remainder theorem and we are going to find out the remainder by substituting x as minus 1. That means we are going to find out p of minus 1. So, go on substituting, solve, and in this case you get the remainder to be equal to 0. Children, when the remainder is 0, we will say that g of x is a factor of p of x. With this, let's move to the next sub-question. Here I have taken the fourth sub-question. The rest too you can try on your own. P of x and g of x are noted. Equate g of x to equal to 0 and we get x to be equal to minus 1. Now we are going to use the remainder theorem as usual. Get the remainder. For that, substitute x as equal to minus 1. After substitution, you need to solve it out. When we solve this particular sub-question, we get the answer to be equal to 2 root 2. Which is not equal to 0. That means the remainder in this case is not equal to 0. As the remainder is not equal to 0, we can say that this g of x, that is x plus 1, is not at all a factor of the given p of x. Now question number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Now this question is again similar to the last question. The only difference here, different set of p of x's and g of x is given. So let's try. The first sub-question, p of x, g of x noted and g of x then equated to 0 to get x equal to minus 1. Next is obviously substitution. We are going to get the remainder by substituting x to be equal to minus 1 and in this case it is equal to 0. Again we can say that when remainder is 0, we can confidently say that g of x is a factor of p of x. Now let's try one more sub-question. The second one, here we have noted down p of x and g of x. Here g of x is x plus 2. So x comes out to be equal to minus 2, which we are going to substitute. We are going to find out p of minus 2. And that will be the remainder. So substitute and get the value of the remainder. The remainder in this case is minus 1. And we can say that g of x is not at all a factor of p of x. Let's move ahead. Question 3. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. Now children, there is a difference in this question. Here we are told that x minus 1 is a factor of p of x. We are already knowing that x minus 1 is a factor. And we are going to find out one unknown number that is there in the p of x. Now, again, we all know that if x minus 1 is a factor, the remainder has to be equal to 0. So, let's see how to proceed in such cases. Solution: p of x is noted, g of x is also noted, and then the third step is equating this g of x to 0. And this is how we get x equal to 1. Now we are going to use the remainder theorem and get the remainder. So, remainder will be equal to p of 1. In this case, it is nothing but 2 plus k. After substitution and after solving, you get p of 1, which will be the remainder. It is here in this case to be equal to 2 plus k. Now, we already know that g of x is a factor. So, we are going to use the factor theorem also. By factor theorem, we can say that p of 1 should be equal to 0. It's a factor, so in any case, remainder has to be equal to 0. So, what we are going to do is, as p of 1 is equal to 2 plus k as well as it is equal to 0, we are going to equate it out. When we equate it, we will get the value of k. In this case, it is equal to minus 2. Now, one more question. P of x, g of x is noted and g of x equated to 0 to get x equal to 1. First, we are going to find out the remainder. So, we are going to substitute x equal to 1 and that will be your remainder. And remainder in this case is 2 plus k plus root 2. You cannot add 2 and root 2 children. So, you will keep it as it is. Next, we are going to use factor theorem. By factor theorem, p of 1 will be surely equal to 0. So, now let us equate those two. I mean, when the LHS are equal, RHS are to be equated. So, this is what you get after equation. 2 plus k plus root 2 equal to 0. And now we will find out the value of k. Take all the constants on the right hand side and k comes out to be equal to minus 2 minus root 2. One more. P of x, g of x noted, x equal to 1. You get the remainder theorem, r equal to p of 1. So, substitution and you get this statement, p of 1 equal to k minus root 2 plus 1. Then you are going to use factor theorem. So, p of 1 will be equal to 0. Finally, equate the two and get the value of k. This is how we have solved few questions of the exercise. We'll come up with the next questions in the next video. Thank you for now.